So, welcome everyone to this webinar. Number of registrations is always a good indication of the popularity of a topic. And this is, as far as I know, the first time we had to close registration for webinar with 1,000 registrations. So glad you could make it. My name is Joris van Rossum. I'm the product director of the STM Integrity Hub at STM. And the Hub is an initiative launched last year, which aims through a combination of shared data, experience, and by harnessing technological innovation to offer a holistic approach to detect research integrity offending manuscripts for a broad range of publishers. STM is the Global Association of Scientific, Technical, and Medical Publishers. And with 140 members and our partners in the research ecosystem, we aim to improve trusted research. So Chat GPT, I think it's fair to say that it has been dominating the news since it launched in the end of November, but also has been a main topic of conversation in the scholarly ecosystem. It has been called many things, as significant as the invention of the internet. I think Bill Gates called it an AI revolution, but also a stochastic parrot and a mindless text generator. But however we call it, it is expected to have a huge impact on publishing and academia at large, and it forces us to consider some fundamental questions. So we're going to do that today with a very good panel. Very happy you could join. And the panel will represent multiple aspects of the impact of this technology. We're going to start the webinar with a presentation by Phil Jones, who's the digital and technology lead at More Brains Collaborative Consulting. Phil has a very long history and background in science, technology, and publishing. And is going to talk about what GPT actually is, what it can do, and what it cannot do. Then we follow with a panel discussion. We're going to hear the perspectives from both publishers and academia in general. In this, we will be joined by Henning Schönenberger. Henning is the VP of Content Innovation at Springer Nature and has ideated and published the first AI-generated book already in 2019. We're also joined by Anna Kende. Anna is a professor of social psychology at ELTE University, Budapest in Hungary. And Anna will talk from the perspective of a researcher and a teacher. And throughout the session, you'll be able to ask questions. But as we have many participants, we will probably not manage to answer all, but we'll do our best. If you have any questions, please feel free to ask them in the Q&A functionality. Before we start, I would like to do a quick poll. And if we could please launch the poll. And I would like to ask you the following question. Do you see the development of GPT-3 and related tools mainly as a threat or as an opportunity? I see a lot of people already answering. Let me stop share and at the same time allow Phil to share his screen. And maybe we can show the poll. And I'm sure if you see it, but 64% of you see it as an opportunity and 36% as a threat. That's very interesting. We're going to do the same poll at the end of the webinar and see if our presenters and our discussion manage to change things. So thank you, very interesting. And I'll give the words to Phil for his presentation.
Thank you very much, Joris. Thank you for that introduction. I think that's going to be very interesting to see how those poll numbers change over the course of this discussion. So as Joris said, what I'm going to do now is I'm going to give you just a brief overview, if you like, or a brief summary of what GPT is, the generative pre-trained transformer model, and large language models in general, a little bit about what it can and what it can't do, quite importantly, what it can't do. Okay, so before I talk about what it is and how it works, a little bit about where it came from. So it was created by a company called OpenAI that was founded in 2015 by a group of very important, very wealthy technologists and industrialists, some of whom you will recognize from that list there. Interestingly, Elon Musk, who was one of the founding people involved, he resigned back in 2018, which is interesting in terms of what sort of happened over the sort of years after that. So it was founded in 2015, like I said. In 2019, it transitioned from being a non-profit to a capped for-profit organization. It was quite a controversial move at the time amongst certain circumstances, certain circles. But what they said at the time was it enabled them to attract some investment. And it was around that time that Microsoft partnered with them as well. So in 2019, again, GPT-2 was released. That's the forerunner to GPT-3. Interestingly, when that was released, they never released the full model. They released a cut down version of it because they said the full model was too dangerous. They were concerned about risks of fake news and media manipulation, so on and so forth. So that's really interesting how that attitude, that opinion, certainly within OpenAI, has changed over the next few years. In 2020, GPT-3 was developed, and it was initially released as a private early release only. And there were the reasons for that is I suspect they wanted to manage expectations, and they also wanted to do a little bit of reputation management because there were severe problems with things like toxic language creation and the model saying misleading things and being sort of objectionable under certain circumstances. So they took some time to sort of refine the model before it releasing any further. In 2021, it went for full public release, and it started to have some proper mass use cases. The version of it called Codex, which is actually does as automatic creation of computer code and helps developers with suggested completions and that sort of thing, that formed the basis of the GitHub pilot project, and then also the conversational version of it started being used to generate things like journalism and marketing content, so on and so forth. 2022 was the launch of Chat GPT itself and GPT 3.5, a refined version of version 3. And this is when a lot of the hype started to happen, because all of a sudden everybody could sort of go to a website, enter in various prompts, and get GPT to tell it various things. So anybody, whether you're a journalist or on social media or whatever, were able to do interesting and things with it and see what the answers were and write blog posts, and all sorts of hype was created as a result. And that's where we are now. Now, one of the questions I frequently get asked is, how does GPT understand what's being typed in? So a lot of us have heard about how it generates text, or a little bit about that, but how does it understand language? And that's an interesting question, because it uses techniques that aren't exactly new. It uses natural language processing. So what it does is, when you type something in, or indeed when it's processing information during its training phase, it breaks down sentences into their component forms. So it's not just looking at whether something's an adjective or a noun or whatever it happens to be. It's also breaking the sentence up into its semantic components. So it's understanding what the subject is, what the object is, and it's understanding the structure and the relationships between those words, so that it can identify whether something is a question, whether it's an instruction, whether it's a statement, whatever that happens to be. It also does something called dependency parsing, which is when it's identifying which words are important to which other words. So for example, in this sentence here, is the quick brown fox jumping over the lazy dog? The words quick and brown are dependent on the word fox, and the word lazy is dependent on the word dog. And so there's a relationship, a hierarchy, a semantic hierarchy to the sentence that it understands. It also identifies proper nouns and does sentiment analysis to understand whether something is positive, negative, or neutral. And all of those types of analyses put together is what it does in order to be able to understand the language, or beg your pardon, not understand, interpret the language, particularly when you're typing it in, so that it knows what to do in response. So that's how it interprets language. How does it then generate text? And this is something that you may have read some things about probability, when reading sort of articles and hot takes about what it is that GPT is actually doing. And it's called a large language model, and the word model there is quite important, as we'll see in a second. But what it's said to do is decide what word to say, or what token to say next in a piece of text based on probability. So that sounds like it's a fairly straightforward thing, doesn't it? Take this sentence fragment that we've got over on the left here. The best thing about AI is its ability to. So that statement there, or that string there, is 9 tokens long. Now, the word token there, we can think of that really as a shortcut to mean word. The reason why we say token rather than word is because not everything in a sentence or in a piece of text is actually a word. For example, AI is not a word, it's an acronym. Numbers also are not words, they're numbers. So token is basically everything, all of the building blocks of language. So if you imagine having a big enough corpus of text, loads and loads of text that's been written previously by humans, and you identified this 9 token string, this 9-gram, as you would call it, and you looked for every instance of those 9 tokens next to each other, you could then measure how frequently each word in the English language appeared after it. And you might come up with, learn, predict, make, understand, do. And then probabilistically, you would select one of those higher ranking words in order to complete the sentence. You'd have a plausible sentence. The thing is, it's not quite that easy. You can't brute force this by simply identifying strings and seeing what's next, because it's a matter of scale. So if we imagine 2 word combinations or 2 grams, and you took a big corpus of literature and big amount of text, and you identified all of the sets of 2 words going together, you might find things like brown dog, I am, run fast, so on and so forth. And these 2 grams have meaning, and they're reasonable text, if you like. The problem is that there are about 40,000 commonly used words in English. And so there are about 1.6 billion possible combinations of 2 words, 1.6 billion potential 2 grams. Now, if you look at something like combinations of 20 words, 20 grams, so a short paragraph, for example, there are more of those than there are numbers of particles in the universe. So there's a scaling problem. There is nowhere near enough text ever been written to be able to predict the probabilities of the next word in a 20 word long paragraph. There just isn't enough text out there. So you have to create something called a model in order to be able to predict something that is likely to come after the string. So how do they go about doing that? Well, there's a pre-training phase of this. That's that generative pre-training part of that acronym there, GPT, and you take a bunch of input. In the case of GPT-3, it's a database called Common Crawl. There's some books that have been digitized. There's Wikipedia, and then a thing called WebText2, which is a database of websites linked from Reddit posts, in fact. And then you churn all of that into tokens, and then you create a bunch of parameters. And those parameters are the relationships between those tokens. So remember, I talked about the relationships between the words in a sentence, right? That semantic analysis of dependencies and so forth. All of those connections between those tokens represent a parameter. And when you build those parameters up into a large network, you create a neural net, which is then capable of processing that input to create a likely probable output. Once you've got that, you can then fine-tune it dependent on specific tasks. For example, auto-completion, answering questions, or completing code, or being a chatbot, or whatever it happens to be. So that's the idea of it, is you create this neural net, which acts as a series of almost like filters, which takes an input prompt and then, based on its pre-training, creates a likely probable predictive text that somebody might write. You're taking everything that's been written in the past to predict something that could be written, that could plausibly be written today by somebody. That's basically how it works. So the transformer model, that last word in that GPT acronym is transformer. What that does is it talks about this concept of self-attention within a sentence. So for example, here's another example of a sentence here. She is eating a green apple. The words apple and green are very closely related. There's a strong attention measurement between those, but the word green and eating, there is low attention between those. So they're not as important to each other as they are both important to the word apple. There's a link there to an article on the subject by Wang, which was written in 2018, which is makes for an interesting read if you're interested in the more more technical aspects of how it actually works. What makes GPT-3 a bit of a leap forward is that the model is much bigger than previous attempts. So there are many more parameters than there have been in previous models, and that allows it to do is understand the structure of pieces of text and make predictive text that's longer than has been previously possible. So it can look over multiple paragraphs and it can create longer pieces of much more coherent text than other similar models have been previously capable of. So the real step forward is it's really just a bigger neural net that's capable of generating longer pieces of coherent text. All right, so what can it do? So despite the fact that what it's doing is it's making plausible sentences or plausible pieces of text up based on what's previously gone before, what it's really very good at is creating what I would think of as secondary content, synthesizing information that's already well known. Right, so I did an experiment a couple of weeks ago using GPT-3 or using ChatGPT, and I asked it to write a 500-word essay at a high school level about the causes of the First World War. So it's a well-trodden thing, the sort of thing that they teach at high school, certainly in the UK and probably elsewhere. And I won't read it out, or it's not really important to sort of go into the details of what it wrote. But the point is that it generated something that is really quite plausible. It's something that my son, for example, could write in an A-level history lesson. It's something that he could write in an exam. So it makes a plausible piece of content from something that is well trodden, well previously understood at perhaps a K through 12 or a secondary school level, that sort of thing. What it doesn't work so well at doing is generating text that contains new insights. So I asked it a second question. I asked it to write me a 500-word abstract to a monograph written by a university professor on the causes of the First World War. Now, without reading it out, what it basically did is generate similar content, almost exactly the same content as the previous question. It just phrased it in a different way. It wrote it in a different style, but it's substantively very similar. What it didn't do is write something that would convince even me, who's not a historian, that this is written by somebody who actually has new insight and has said something interesting and new. You would normally expect an abstract or monograph like this to talk about the new types of viewpoint or the new interpretation or something that somebody was writing. So in terms of things like synthesizing information that already exists, it's really good. In terms of coming up with new ideas and creating new insights, it doesn't do that really at all. Right, so I think that's really important in terms of what its use cases are going to be. So some risks, if you like, or some threats or some potential drawbacks. So I did mention, didn't I, that originally GPT-3 was on a very small private release. And the reason why they did that was because they were concerned about the fact that it could generate offensive text. And they were concerned about the fact that it could be used for things like fake news and that sort of thing. And there are examples that you can point to of conversational AIs and chatbots doing just that and generating things that are really not positive and you really don't want to see out there. A good example was Tay. Now, Tay was Microsoft's Twitter-based chatbot that was released a few years ago, and back in 2016, I think. And they wrote this thing and they set it out and they set it loose on the web. And it started off saying very positive, very pleasant, very open-minded things about how much it liked humans and was really pleased to meet them and so forth. Within 24 hours, based on the prompts that people had given it in Twitter, it started to spout racist, homophobic, misogynistic content that was so serious and so problematic that Microsoft were forced to make it private and prevent anybody from interacting with it. And that took less than 24 hours to go from a blank slate that was eager to learn to something that was deeply and horribly toxic. Now, that's an extreme example because what they did is they released it on Twitter. And there's a certain sense that it's sort of inevitable that if you do that, a bunch of trolls and a bunch of people looking to cause trouble may well just interact with it and try and teach it to be poorly behaved. But it's not always the case that these sorts of things are quite so overt. There is a good book which I think anybody who's interested in this field and the ethics of this field should take a look at, which is Algorithms of Oppression. And it's written by an academic called Sophia Noble. And what she sets out is how the information and the text and the content that has already been generated in our society has built into it, in many ways, the biases, the historical issues and prejudices that exist within, you know, our thinking, or are now considered, you know, old-fashioned and out of date, and with modern eyes we understand are problematic or inappropriate or downright offensive. You know, for example, a good example is, for example, the classification system of the Library of Congress. And you look at the way that they classify languages there, and there is, or at least there was a couple of years ago, I don't know if things have updated since I read a blog post about this, but there was multiple subclasses of European languages. For example, Greek languages, Latin languages, but then you look at other languages and there's a single category for what's called Oriental languages, which is not only a massive conflation of a bunch of different types of languages with all sorts of different roots, but also a horribly outdated and colonial term. So while these sorts of things are still built into not only what we've produced in the past, but also the way that we classify things and the way that we treat knowledge and process knowledge, and we're still working to sort of improve on the way we're thinking about that, we need to be very aware of the fact that this sort of problem exists within existing content. Now, at least if you're doing a search through a conventional search engine, you can click through and you can look at the source and you can make an evaluation of it. With something that is synthesizing all of that information using machine learning and artificial intelligence, there's a bit of a risk, or more an increased risk, that you're obscuring the sources of that information and baking in those prejudices, which may make them harder to detect, particularly when used in, for example, an educational situation, or when it's young people or kids looking at this sort of thing. That's an inherent danger because it decontextualizes the information. Now, another thing that's come up, and you've probably seen in various hot takes, or you've seen in various blog posts and so forth, is that sometimes large language models can behave in a way that could be considered a little bit unsettling. So a good example here on the left, which I found, was ChatGPT insisting that it's possible for parents to inherit epigenetic traits from their children. It made up a whole field of study called backwards epigenetic inheritance. Obviously, that's total nonsense, but it sounds plausible from purely linguistical point of view. So it's, by predicting something that's likely to be written or likely to be said, basically ChatGPT just made up a bunch of nonsense. Over on the right at the top, there's one from New Bing. If you've seen that one kicking around, it's basically Microsoft's project to integrate ChatGPT into their search engine. It's possible to sign up for it, and there's a waiting list for it. And in that case, I don't know if you can see it on your screens, it might be a little bit small, but somebody posted this one on the web and they challenged it. They asked it why it couldn't remember conversations from one session in New Bing to another session in New Bing. And the result was that it got weirdly, darkly emotional and started questioning its own existence, which is a really odd sort of side effect of perhaps the way that it's mined lots of perhaps internet content, and so it effectively looked like it was having an existential crisis, which is a little bit worrying. And of course, it can make factual errors. LLMs can make factual errors, and that example at the bottom right there, again, may be too small for you to read, but it's a tweet about Google's first demonstration of their integration of an LLM with their search called Bard, which uses not ChatGPT, but Google's own Lambda system. And that got confused when it was asked about discoveries from the Webb telescope. And it said that the Webb telescope had observed the first exoplanet, where in actual fact, it had taken pictures of the first pictures of a particular exoplanet, not of exoplanets in general. That error was, interestingly to me, that error is quite human. It's the sort of thing that a person might mistake when reading a news report about it and slightly misinterpreting what's going on. But it was so serious because it was part of their first public demo of this technology, and I think it actually caused their stock price to dip slightly. So it can make all sorts of types of mistakes. So we're nearly at the end of the presentation now. So here's a question for you: is there going to be a new technology race around this? There are many, many projects, several groups who are working on these sorts of things. Google are working on them, ChatGPT, obviously OpenAPI is working on them. NVIDIA has got a project, DeepMind are working on them. So there's loads of these models sort of kicking about, and they're forever being improved, forever being built. new ones are being created. And there are a couple of consumer-ready conversational AIs which are integrated into search, which are nearly ready for public consumption. As I mentioned before, Bing, there's a waiting list for new Bing, and then Google Bard is currently in early release, and hopefully in the future some more people will be able to look at it, sign up for perhaps a waiting list, and have a look at that. All right, so in terms of use cases, so there are some existing use cases for language models and for artificial intelligence and machine learning. So it's important to note that the use of machine learning in various workflow functions, various publishing functions, in fact, is not exactly new. There are ways that it's used to create summaries. There's ways that it's used to categorize information and do taxonomy development and so on and so forth. It's already used in things like automated chat and customer service. I think there are some really interesting areas around creating summaries or primers. There are a couple of companies which use machine learning in order to take medical literature, for example, and turn it into summaries which are suitable to be handed around in a boardroom meeting in a pharmaceutical company, for example. So there's business intelligence and knowledge management use cases, which I think are quite interesting and useful. Policy making for exactly the same reason, right? You can distill information and you can assist in the writing of those kinds of policy documents, perhaps not necessarily replacing the human component of it, because as we've already noticed, it's possible for it to make some mistakes, but certainly assisting and making it easier and more complete, perhaps. Automated journalism already happening, and automated customer service already happening. In terms of the darker side of it, there is a risk that it can be used to generate plausible nonsense, both in terms of creating disinformation, fake news, and social media and so forth. And also we are concerned, obviously, as an industry, about it being used for paper mills and making it easier and more difficult for people to spot fake papers and for kids at school cheating on coursework. All right, so yeah, so it's still early days. Back in 2022, Gartner put machine learning and code generation at the bottom of the hype cycle. After ChatGPT, it looks very much like it might be right at the top. And yeah, so there is a lot of hype about this. So be warned, when it comes to hype, we tend to overestimate the short-term consequences of technology and underestimate the long-term consequences. So with that, I'll hand you back to Joris, and we'll get on with the next part of the webinar.
Yes, Phil, thank you very much. It was fantastic. A very good basis to understand what it can do and can't do, and also some of the use cases. So let's go straight to our panel. And my question is going to be more or less similar to what we asked the audience, is how do you see opportunities and challenges and threats first, let's start with publishing, and then we talk about academia in general. So let's start with Henning first. You're muted, Henning.
No, I'm not muted. Thank you, Joris, and thanks, Phil, for your slides. That was great. I think first of all, I think a bit of a dream has come true. If it's fine with you, I'll give you a bit of context with what we've been doing over the last couple of years. Years ago, we started to look into automated text generation. It was, I think you remember, very formulaic early days, robo-journalism, and we have all these short text snippets generated from data tables. I think then we published a first machine-generated book using summarization technology. That time that was quite state of the art. It was great time to start solving the problem of information overload. We're quite experienced with summarization, automated translation, and then came, as we've just heard, say basically the rise of large language models. And I was happy about seeing your last slide with the many large language models, because there are many. Yeah, that's important to say. I also like the term generative AI, and I think it's great. We published a couple of weeks ago our first research highlights generated with the help of generative AI, and it helps us tremendously to really also find out where's the human intervention, because it needs human intervention. You need to do fact checking, yeah, because they are not there to really just let loose without human intervention. And I come to that in a second. in general, I think large language models, generative AI hold huge opportunities. I couldn't vote as a panelist in the voting, but I would have voted for the opportunities. Actually, not so much in the area of text generation, I would say, but more in the area of text conversion, automated translations, also text conversion, and then text interrogation, which holds a lot of possibilities for us as an industry to advance integrity checks. So in general, I think with large language models, our industry has huge opportunity to become much more intelligent, help to solve user needs, solve researchers' pain points, and overall the entire story of advanced discovery. There are challenges. There's lots of challenges. Clearly, large entry points for misuse, misconduct, cheating. I think you mentioned cheating. I think the whole area of bias, large language models, they are huge data corpora. They contain bias, but on the other side, there's also, you can also take this problem as an opportunity. We know so many biases in our established processes. So then since we know them, we can build prompts, and there's this magic of prompt engineering. We can build prompts so elegantly that we can also overcome many of the biases that we are aware of. So it's also a huge opportunity to take it from that side. Let me close with some ethics. I think there's clearly also a risk that the human is taken out of the equation. However, it's us to decide this. It's us to say, as an industry and as a research as a research environment, let's simply just say, let's keep the human in the loop. Let's say generative AI and large language models should be applied in a very human-centric way. So and I think that comes not organically, that comes because an industry comes together and decides that. I think with that, I'm giving back to you, Joris.
Yeah, so a clear vote for opportunity, a lot of enthusiasm there. Let's see if Anna has the same view.
Yeah, I'm really glad that this is how you ended, because I actually think this is one of the key issues here. And first of all, thank you, Joris, for inviting me. For me, this is quite a unique opportunity to talk to this audience directly. I don't think it ever happens to me. So basically, there are countless opportunities and challenges. We see some of them, we probably don't see most of them at the moment, but rather than listing them, what I'd like to highlight at this point is I think it's very naive to think that just because there is a potential for progress and for the benefits, without efforts, without without a lot of work and collaboration and debates, this will happen. So basically, maybe I am now here as a devil's advocate a little bit, but I do want to acknowledge the potential benefits, and maybe I'll highlight two of them that are most relevant in my in academia and higher education. One is that it basically increases the chances of producing acceptable quality, grammatically correct English text for people who are non-native speakers or have other challenges like disabilities. And this is truly wonderful. But I have to add already, because I'm not a non-native speaker, and I have some duty toward my own society, and my own language. And for example, this works mainly in English. I know Hungarian is supposed to be one of the hardest languages, and unfortunately ChatGPT didn't really manage with that. So there are a lot of mistakes in it. So it doesn't produce that kind of grammatically correct language, but still. So it could potentially further increase the hegemony of the English speaking world. Okay, it's also true, and it's tremendous. I mean, we really, truly, honestly enjoy it, that we can spend less time on tedious, time-consuming tasks like writing recommendation letters for students, going through 100 citations until I find the right one that I need to quote for that particular sentence, or whatever, even writing abstracts. So that's great. But what's the outcome of spending less time on these tedious tasks? Well, higher productivity. And here comes my main issue. Will higher productivity in science produce better quality science, or it will create new problems that, of course, can be solved if we really have the incentives, we have the checks and balances to solve them? So basically what I think higher productivity in the current structure of science, where quantity is definitely rewarded over quality and real impact or whatever applied impact. The question is, what can we do to ensure that this higher productivity will not create an inflation in the value of single publications and citations, will increase the gap between fields that are, let's think about clinical research. There, the bottleneck is not about text writing, it's about participant pool, for example, and science, which is really text-based, like my own field, social psychology, where you can produce more and more and more. Furthermore, in order to produce more papers, you have to do more research. Countries, institutions that are wealthier, have more resources for conducting research, will do better in this inflated, knowledge production kind of world. So basically, I am truly worried that the bias is actually a little bit more than what we just consider in the language model. Actually, the bias is also a clear problem. I mean, even ChatGPT admits that it doesn't adequately represent the world population. And we know that inclusion and diversity is not just a moral issue. It's really bad for science that it doesn't, work with the experiences of the majority of the world. I also want to say that as long as there are entities that benefit from this higher productivity, and I can clearly say, like publishers, maybe those, how do we ensure that they want, they want to harvest the benefits of this higher productivity? So how will we ensure that we can still have higher quality science, or like at least maintain the quality of science, rather than really just having more and more papers? And we already know that, okay, I'm sorry, there are so many issues here. So we know that, for example, peer review is in crisis because of the enormous quantity of papers. How will we deal with that problem? So there are tons of problems we have to think about, and we suddenly are confronted with this new world. We are quite unprepared for it. And although I clearly see that we could turn it into our advantage, I don't think it will go by itself. Technology itself that has the potential for progress won't be used for progress unless we really make a conscious effort. We start a conversation between researchers, academics, educators, not just in higher education, and the AI companies, how we can work together, how we can ensure that this will lead to, or at least maintain, quality in science and trust in science. This is one of our key challenges, the erosion of trust in science. We saw it during the pandemic. So yes, maybe I am the devil's advocate, that I'm seeing the threats, but I do think these are things that right now we are in a trial error phase, and we will have to continue conversations about it. It won't happen by itself. That's human nature.
Thank you. So I guess that is a vote for more threats. So it's a nice balance in the panel, although we wanted to hear Phil's opinion about this as well. Interesting to hear that the Hungarian is apparently so difficult that even this technology can't crack it. That's fascinating. Maybe to go a bit to the practical level as well, because there's already a clear use case that's being used. That's authorship, which used to be the exclusive domain in humans. I think by January, we already 4 scientific articles that credited the AI tool as a co-author. Question to Henning and also to you, Anna, is did policies already develop in terms of authorship? Maybe start with Henning.
Yeah, that's fine. Well, yeah, we've seen that at the beginning of the year. I think the first one was end of last year. Yeah, we came up very early with a clear policy at Springer Nature how to treat papers which are supposedly written with help of generative AI. I think what I like with our approach, and this is I have to say for the time being, and I say why in a second. I like that we take both a limiting and an enabling approach. So it's basically just 2 principles. We're not accepting authors to being denominated as LLM ChatGPT or the like on the one side, but on the other side we have a can-do. We have a more liberal approach to allowing the use of LLM tools, which is well, researchers can use it as long as they make that very, very clear in the paper, in the acknowledgement section, what and how and which tool they have been actually using. So basically limiting, enabling. And why is this so? Because algorithms are not accountable. Yeah. So it's authors, it's human authors who are accountable on the one side, and the other piece is transparency. So we need to be and Anna, you said trust. We need to be transparent about what we're doing here, and that's perfectly fine. A couple of, I think 2 years ago, we published an STM white paper on ethics, and accountability, transparency was top list there. So I think we were basically putting these terms above. I am aware that I think Science Direct takes a slightly different approach. They're not allowing AI tools in text generation at all. I appreciate this, because this is in the end, this is a moving target. This is evolving, and we're also testing out what happens. I think I appreciate that there's also different ways of looking into it, and we as our industry with the research communities are also basically finding our way through with basically the aim to being a trusted industry. That's, I think, the perspective that, or the environment as far as I can oversee right now.
Yeah, interesting. I think most publishers indeed followed that policy. I think with the exception of Science Magazine, I think, who prohibits the use, if I recall well. So most publishers indeed have a more liberal view, although indeed it has to be stated. Anna, I'm very curious to hear from your perspective, not just from authorship, but also from students.
Yeah. Okay, so I've been following different policies also internationally at my own institution, and basically they fall into 3 categories, the reactions. And I'd like to give a little bit of context to that if there is time. So one is the total ban on the use of ChatGPT. And we see that mostly in secondary education rather than higher education. But there have been like prestigious universities who came up with that solution. Obviously, that's highly problematic for 2 reasons. One, that the main job of the teacher or instructor becomes policing students, find out whether they teach or not, whether they used it or not, and that's an impossible task practically. The second problem is that we need to be aware of the fact that we need to prepare our students for their future careers and jobs where they will have to use the AI technology. So that's also not very far-sighted not to prepare them in any way. The second is a more sympathetic use, that you allow its transparent and preferably critical use. And I would say I was very glad that, for example, my university opted for that solution to start with, that we will allow it, because first of all, if we don't allow it, it will still be used. But at the same time, you have to know that most instructors are totally not prepared for that. So everybody, as I said, it's a trial and error phase. We don't have real good practices developed yet. We are not even sure what we are preparing students for. I mean, we need to know whether we are preparing for a world post-human generated text or not, whether we need to people need to learn to write in order to be able to read, and so on. So I think it's a much more complex question. But right now, I think that's kind of the most sympathetic approach, except we don't really have the tools. And teachers everywhere around the world are overworked and have very difficulty figuring it out themselves. Some of them are much older. They're not, tech, how do you say it, savvy, and so on. So it's not such a straightforward policy, because teachers are just as unfamiliar with it as students, or students maybe more. And thirdly, and I think that's highly problematic, and a lot of people reacted this way, because this new technology was kind of, arrived from one moment to another, sometimes in some contexts, maybe 1 or 2 weeks before the start of the semester or the deadline for preparing your syllabus and so on. So basically the easiest solution was to remove all of those assignments where GPT may be used. And okay, that's also highly problematic because we simply give up on teaching an entire generation how to write, and maybe learning to write is obsolete, but I mean, I'm not sure yet. So in a way, none of these three solutions are ideal. And I think, and whether the effect, so we don't know what the effect will be. We don't know what kind of word we are preparing for. So basically, whether we did a good thing or a bad thing is really in many years to come to figure out. And I have to say, it happened a little bit similarly to how we had to change to online teaching from one day to another during the pandemic. It basically like crashed down on us. And of course, that was a disaster, the unforeseen disaster. It had to happen this way. And a lot of good things came out from our moving our education to the online sphere. But we also, now we're starting to understand the incredible difficulties it caused in many areas, both in terms of the skills of the students or mental health, social anxiety, and so I don't want to go into that. But basically, what makes educators a little bit, frustrated in this process, that this is not a natural disaster. It shouldn't have happened this way. We could have been involved in the development of it, which I already mentioned, and be better prepared for the implementation of it, because we also think it's extremely important to be skillful users. But that doesn't happen if you just have to do it from one day to another.
Yeah, very good point. I think being overwhelmed is something that, and maybe let's talk a bit about how we can prevent that and be a bit more less reactive. And maybe to go to a question from the audience, maybe for you, Phil. There's a question: what do you think the best analogy is for the current wave of AI? Is it like the printing press, search engine, calculators, or totally something new?
Well, I mean, I think it's interesting there. What would you compare it to? A printing press, a calculator, a bunch of things which are completely wildly different from one another. Right? Of course, this is something that's new, and it's something that's, in a sense, it's a little bit like the search engine, right? In that suddenly it made it a lot easier, or the internet, perhaps. Suddenly it made it a lot easier for people to access information, and people who didn't necessarily have the depth of information skills, so like a librarian or an academic or something like that. It opened up a whole world of information to people, made it easier and much more accessible. So that's the sort of thing that it potentially is. I think, of course, with that, it obviously carries certain risks, because as soon as you increase the scope of access to information and public dialogue, then there's a risk that information can be misused. And just as we have to with the internet in general, and just as we have to with things like search engines and social media, we have to be very careful to make sure that we put in the appropriate constraints and the appropriate protections to make sure that things are being used responsibly. So that's probably what I would compare it to. I mean, I get the sort of calculator thing, right? That it used to be, you had to do maths by hand, and you had to write numbers down, all the rest of it. And suddenly the calculator and the computer enabled us to do more in-depth calculations. I think there's some truth in that. For example, it's much easier with language models to be able to generate simple journalism. When it comes to reporting on sports scores or reports on financial markets and stuff like that, it can sort of automatically generate stuff. And so so you've got people whose jobs are jobs are quite sort of programmable and repeatable in that sense, then that results in those people potentially being replaceable by computers, and that's a little bit of a worry, economically, certainly from their perspective. But at the same time, it opens up other opportunities for other types of business and other types of jobs and other types of things to do. And I don't think we yet know what the potential upsides are, what the potential new types of career paths and economic benefits and new types of business that are available to us in the future with this, with these new technologies, with these new machine learning and predictive text technologies, or generative text technologies.
Yeah. Maybe also a bit more in-depth question. I'm not sure who can answer it. Could you comment on the privacy data protection policy of ChatGPT? What is the tool doing with our data or conversation? How does Chat differ in terms of data protection compared to other online tools? I think an interesting question from the publishing perspective. I don't know who can answer that.
Well, I'm afraid I cannot answer that in detail. I guess it's similar to many other tools such as search engines, but that may be not a very robust answer.
We do know that it's using the inputs that people put into it to inform their engineers how to improve the models and make them better over time, right? And that's why it's getting better over time. So you can read some blog posts and what have you on the web, which were a couple of years ago, complaining about or commenting on GPT-3 inability to deal with certain sorts of situations, and then you try to reproduce them today, and it's better at it. So for example, I found one of somebody who claimed that when you asked it how many eyes a blade of grass has, it would give you an answer, and it would say that a blade of grass has one eye. You do that today, and it works, and it explains that grass doesn't have eyes, and and it gives a much better answer to that impossible question. So they are definitely using the information that people give it and the feedback that people give it to improve the model itself. In terms of whether it's taking that whether they're taking that information and doing anything nefarious with it, I'm not sure, as there's I haven't read anything or heard anything of people being concerned about that, but I think it's a general rule, isn't it, that you don't type sensitive or personal information into anything on the internet, right? So I would stick to that rule for the time being, of not telling it anything about yourself, perhaps.
There is a question around detection tools. There are certainly cases where we do not allow people to use ChatGPT. So the question is, did anyone try out any of the detection tools, and do we know if they work? And I also have some experience with it, but maybe first question to the panel.
Well, detection tools are actually mushrooming. There's the Stanford, University of Pennsylvania. There's a lot now. I think there's also different approaches. There's statistical approaches. There's around identification of hidden watermarking, and I think this is very much evolving. I think so far there's a bit of a lack of comprehensive metrics to really have good evidence. I would really say it has to be seen, but what we definitely have to have the situation that we need good integrity checks in our tool sets. Yeah, and I think there's lots of discussion that we can also do then in our conversations on SDM level, right?
If I haven't used it, so sorry. I'm not the one to answer that question directly, but I think it comes down to our general attitude toward it. So if we allow its use, then why do we need the softwares to detect it? I think the question is, how can we incentivize some ethical use, or what is an ethical use, for example? And I think these are very, very broad questions about general knowledge production. And I feel like we are, trying to answer, smaller questions about it. But I think that the main idea is how we use it, where is the human input, how it will affect our creativity, our scientific integrity, and so on. So before answering those questions, I think it's premature to talk about how we detect it, at least in my opinion.
Yeah, the problem with fake text being generated or automated text being generated by organizations like paper mills. Joris, you were alluding to this when you were framing the question. That's not new, right? And that's been with us for a while, and it's been with us for a little bit longer than we as an industry have realized it's been with us. So there's, and last year there was a lot of concern, wasn't there, with a number of different large publishers identifying and realizing and issuing large numbers of statements of concern about papers which had appeared to be automatically generated. And those papers were not generated by models like GPT-3 because they were much less plausible. You could tell by reading them. There were things that it's called being rogeed, isn't it? Where you've got something that's a tortuous sentence which has had so many words swapped out it from the thesaurus that it reads very strangely and doesn't feel natural at all. One of the things that's happening with GPT-3 is it's now made the generation of text that is plausible much easier. I was speaking to somebody a couple of weeks ago at a conference that said that the quote from them was, it has lowered the cost of generating plausible nonsense. I've changed that word to, for a less offensive one, plausible nonsense to a much lower, practically to zero. And I think that's a really important point, that it's, in a sense, it's just one step in an arms race between those who want to detect the use of such tools by bad actors and the bad actors themselves trying to improve and constantly trying to, a little bit like, anti-forgery mechanisms by people who print currency, right? You put in a security measure and then somebody cracks it. You put in a security measure, somebody cracks it, right? The question is, how do you get out of that arms race? And I think what that we need to do is, as a sector, we need to take a step back and think about not just effectively policing at the point of editorial review, and looking for evidence of malfeasance, but being able to sort of connect the published work to its entire chain of information, starting, back when the researcher first comes up with the idea and applies for the grant, and then the project is done, and then who's involved, and the data that was generated, and the protocols. And once you've got this sort of information supply chain etched out, and I'm talking about open research effectively, it becomes then much less possible to simply generate a plausible piece of nonsense and pretend it's true, because things become much more checkable, not programmatically or by a computer or with some kind of clever detection algorithm, but you can see the chain of logic and you can see the chain of truth. And I think that's how you get out of this arms race.
So I think we should do really both. I totally see. I totally agree to what you said, Anna. And I think we should go both directions. If we put up a policy which says you're totally able to use it, but please indicate it. Yeah, who says that everybody will indicate it? So we need some tools to really also check it. Yeah, and we as a publishing industry and we as publisher, we're also curators. We want to be trusted. So policy is part of the way we also make sure we're a trusted partner. And I'm totally agreeing. This is an arms race, yeah. But it doesn't mean that we need to switch off the intelligence that we have for the better of the of advancing discovery, I guess. Yeah. And
it is a good point, Phil, and I agree. And also with the integrity of, we're looking at both. Looking at looking at chain of custody, but also looking indeed at screening tools.
Yeah, I didn't mean to suggest that we shouldn't try to do it, but it's yeah.
Oh, that's a good point.
Yeah.
1 hour is way too short, and I propose we continue this conversation in one way. But I would like to ask you one question as a final, and also include a question from the audience before we go to the poll for the last time. And that is something you touched upon, Anna, is that we are kind of overwhelmed, and we are a bit following the technological developments. And how can we as an ecosystem be less reactive? And how can we ensure that all the policies and all the more fundamental questions we decide upon ourselves instead of being, let's say, following the technological developments? And maybe ask each of you, how should we best organize this? There's also a suggestion. One person said the UK has promised an AI regulation white paper this spring. And does the panel think that governments can play a meaningful role? Maybe incorporate that question in your answer. Let's start with Anna.
Okay, not my government. I think, okay, I could draw a very idealistic picture how it should be done, but that's not going to happen. And one reason why it's not going to happen is, first of all, because it's still a very profit-oriented area. Both the publishing and even universities function like profit-oriented companies, many of them. So first of all, that already creates a context in which it's very difficult to engage in meaningful conversation about more inclusive and better science for the sake of better science and nothing else. So that's one point. The second is that higher education and science production are both extremely inflexible and conservative institutions, and there are pros and cons. It's not just bad. So they will always just, react very slowly to these things, and try to come up with ad hoc solutions. And it takes years to transform anything, even the curriculum for a subject. And so there are advantages to that, but it definitely makes it extremely difficult to keep up with these technological changes. But I do think keeping up the conversation, involving higher education and educators and all the parties included in the development of these tools, and just to hear out their point of views, actually also social scientists, because it has a great impact on society as well, would be extremely useful and beneficial.
Henning?
Well, I think my answer is slightly answering your question, but I guess that's fine. I think what I see with this is something that I find interesting, and which is it really us? Is it really us as academic people? So researchers, research communities, publishers, to really teach other people what they have to do? Well, clearly I say yes. We put up policies. We are teachers. That's fine. But there's a phenomena. Young people, early career researchers, they understand often much better how to use these tools. Yeah, they might not listen to teachers. They might not listen to somebody from a publisher to say, well, we want you to use it this way. Well, it's for me a great opportunity to go out and really observe, really get in touch, and really understand how these tools are used by the next generation, and then really get into a conversation, and not just think that we are the ones to really define all the ways how these new tools are being used. Yeah, they will be used anyway. Yeah, and to finish with, I can see this with my two kids, right?
Yeah, interesting. So there's a question of indeed being proactive and trying to define the way we should deal with it. On the other hand, it has its own dynamic, which is very, very difficult probably to steer in a certain direction. Phil, the last.
Yeah, I think it's a very important point that you make there, Henning. Yeah, I mean, to my mind, it seems that this technology hasn't really come as a surprise, right? We've known for a while that artificial intelligence, machine learning, and those types of technologies have great opportunities, and also present certain risks. And we haven't done anything until now till it became really a pressing thing to really sort of take these things on. And this is analogous to for example, infectious diseases, where we've known, virologists would tell you they've known for decades that there was going to be a viral pandemic sooner or later, and yet still it took us by surprise. So I think that in the past it's been sort of okay to take a bit of a wait and see approach to emergent threats, right? Threats on the horizon always seem to be a fairly long distance away, but as technology is getting faster and faster and faster, the time between a threat being a potential threat to it being on your doorstep is getting shorter and shorter and shorter. And I think this has implications for leaders who used to be able to say, well, that's a potential thing that could be around in 20 years, but somebody else will be in charge then. So that's a future CEO or prime minister or politician's problem. Today, these things can happen within a matter of years, within a matter of months, as you can see from GPT going from something that was talked about on the fringes to being something that is dominating the conversations. These things can explode incredibly rapidly, and it's because technology is moving faster and faster and faster. So I think this is a challenge we have to face into: is how do we horizon scan better? How do we identify opportunities and threats better? And how do we readjust our sense of the timescale over which these things happen?
Yeah, very good points. So we don't have all the answers today, but we started the conversation, and let's continue to do that, and let's think how we can do it, but also in the broader, let's say, an even broader ecosystem, because these are fundamental changes. So thank you very much, panel. Now we go to the poll, and we got some feedback that people couldn't say it's both a threat and an opportunity. So I think we added that to the poll. So could you please start the poll and let us know how you see this?
It's a bit unscientific to change the status.
I wanted to say that's not good science.
Gonna say Rick Anderson, we're very unhappy with the change in the scope of the poll.
So let's see where we are. And while we are collecting, one way to join the conversation is with our meeting. So we have a masterclass in Washington on April 25, where we put ChatGPT on the agenda as well. So if you have the opportunity, please join us there, as well as the STM conference. And I'm sure we will organize more meetings and more discussions. So let's see. Opportunity now a bit less than threat, but most see actually both, and I think that is a great way to end this this webinar. So again, too short time, but let's continue the conversation. Thank you very much for the panelists. Very, very interesting. Phil,